Hi everyone, today I'm going to be showing you how to execute two scheduling algorithms. A scheduling algorithm is the algorithm which dictates how much CPU time is allocated to processes and threads. In this video, we'll be looking into two algorithms. The first one is the non-preemptive shortest job first, or also known as shortest process next. The second one is preemptive shortest job first, or also known as shortest remaining time. Both these algorithms will choose the processes based on their burst time. If we take a look at this table, we can see that there are processes P1, P2, P3, and P4 with their own burst times, priority, and arrival times. First, we'll be looking into the non-preemptive shortest job first algorithm. In this algorithm, the process with the shortest burst time will be executed. There will be no interrupts since it is a non-preemptive, and we must also consider the arrival time of each process. We will get into that in a bit. So, here is the same table from earlier. Assume that now the time is 0 ms. Notice how P1 is the only process that has arrived. Since this is the case, P1 will be executed by the processor. P1 will be fully executed at 20 ms since there are no interrupts. When drawing the process in the Gantt chart, we need to add the burst time of that process to the current time. In this case, the current time is 0, so now we have to add 20 to it. Now that P1 has been fully executed, we can cancel it off the list. The time is now 20 ms, as the burst time for P1 was 20 ms. As we can see here, all the other processes on the table has arrived. So now there won't be any new process arrivals. Out of all the remaining process, P2 has the shortest burst time at 4. So P2 will be executed next. So now the current time is 24. Since P2 has been fully executed, we can remove it from the table. So now the only remaining processes left are P3 and P4. Out of the both of these processes, P4 has the shortest burst time at 8. So P4 will be executed next. So now, the current time is 32. Since P4 has been fully executed, we can take it off the list. And P3 is the only process left right now that can be executed, so it will be next in the Gantt chart. Okay, so now it's 42. So, all the processes have been executed. Let's just clear that part up. Okay. Now, the next thing we're going to do is to calculate the waiting time of each process. To calculate waiting time, we need to subtract the arrival. Oh, I'm sorry about that. Alright, sorry about that. Okay, so to calculate the waiting time, we need to subtract the arrival time from the process from the response time. So, as we look here, the process time of P1 is 0, so its the arrival time was also 0, therefore the waiting time is 0. Okay, for P2, this time, in which it was executed at 20, its arrival time was 2. This means that the waiting time for P2 is 18. And for P3, the response time was 24, minus the arrival time, which means the waiting time is 20. And lastly, for P4, the response time was 32, its arrival time was 6, and that leaves an arrival time of 26. So, now we're going to calculate the average waiting time of the process. Also, when calculating the average time, we need to sum up all of the waiting times from each of the processes, and we need to divide that total with the amount of processes in the table. So, in this case, we need to calculate the sum of 0 plus 18 plus 20 plus 26, and we need to divide the total by the amount of processes on the table, which in this case is 4. So also this leaves with an average time of 16. Yeah, 16. So now we're going to be looking into the preemptive shortest job first algorithm. Okay, when it comes to this algorithm, process with the shortest burst time will be executed just like the non-preemptive shortest job first algorithm. We must consider interrupts, which is the arrival of new processes. And just like the previous algorithm, we must consider the arrival time of each processes. Okay, this is the same table from earlier. Assuming again, the current time is 0, the only process that has arrived is P1, of course, which means it will be executed first. We also need to consider the arrival time of the next process, as its arrival will cause an interrupt. So, in the Gantt chart, P1 will only be executed for 2, as the arrival of a new process has interrupted its execution. The current time is 2, which means P1 and P2 are ready for execution. As we see here, P2 has the shorter burst time of 4. Therefore, it will be next process to be executed. Okay. But don't forget, we also need to consider the next arrival time of the process, which in this case is P3 at 4. So, P2 will only be executed for 2 as P3 has arrived. And since it has been executed for 2, we can subtract from the initial burst time of 4. The current time is 4, which means that the process is ready to be executed, and are P1, P2, and P3. Okay, so now P2. Okay, I did something wrong here. P2 again has the shortest burst time of 2, which means that in the next process to be executed, it can be fully executed. And this time, the next arrival of P4 is 6, which is just about the time it fully finishes executing. Since P2 has been fully executed, we can cancel it off the table. Now, we don't have to worry about any other new processes since all of the processes in the table has arrived. And now, among the 3 remaining processes, P4 has the shortest burst time of 8. Therefore, P4 will be executed next. This means that the current time now is 14. Okay, now P4 can be taken off the table since it has been fully executed. Now, there are only 2 more processes left to be executed, which are P1 and P3, with the burst time of 18 and 10 respectively. So P3 has the shortest burst time at 10, which means P3 will be executed next. As you see here. Did I go too fast? Okay. Alright. The current time now is 24, so P3 has been fully executed, so we can remove it from the table. Which means that now the only process left is P1. So, what we have to do is just add P1 to the Gantt chart. There you go. Alright, just get rid of that. Alright, now we need to calculate the waiting time of each process. Okay, for P1, the response time was 0 and 24. The arrival time was 0. In the Gantt chart, we can see P1 twice. And when this happens, we need to subtract the first arrival time from the first response time. Then we need to subtract the time it was interrupted from the next response time. In this case, P1 was interrupted at 2. So we need to subtract 2 from the next response, which was 24. This gives us a waiting time of 22. Okay, for P4, just repeat the same process. The response time was 2, arrival time was also 2, therefore P2 had a waiting time of 0. This is easy. Okay, the response time for P3 was 14 and the arrival time was 4, which means that the waiting time was 10. So for P4, the response time and arrival time was 6, which means it had a waiting time of 0. 6 minus 6, 0. Okay. So now we need to calculate the average waiting time. So 22 plus 0 plus 10 plus 0 divided all by the number of processes we have, which is 4. That will give us an average waiting time of 8. Okay. That's it for this video. I hope that all of you have enjoyed this video, and thanks for watching. Also give a big thumbs up if you learned something new from this, and yes, thank you for watching.